In this video, we're going to talk about 12.6 Objective 1, where we use DeMoivre's theorem to find roots or powers of complex numbers. I'm going to show you the method that they want you to use here for my labs. When we get into later problems, you're going to see how it gives you an approximately right answer. Calculator gives you a better answer. Let's go ahead and get started here. DeMoivre's theorem says that if I take the complex number in polar form r times cosine of theta plus j sine of theta, and I raise that to the n power, then I'm going to get r to the n times cosine of n theta plus j sine of n theta. And then I can simplify n theta down to an equivalent angle that's between 0 and 360 degrees by subtracting multiples of 360 if it's too big, which we're going to do here in just a little bit. But let's go ahead. I'm going to show you how to do this in your MyLabs assignments. So let's find our r by saying r is the square root of -2 squared plus -4 squared is the square root of 4 plus 16 is square root of 20. And then square root of 20. MyLabs wants you to round this to 2 decimal places. Everything. They want you to keep rounding everything to 2 decimal places. So 4.47. And then when you find r to the 5th, I want you to take just the 4.47 and raise that to the 5th. Then they want you to round that again to 2 decimal places. So 1784.59. And that's going to be 1784.59. That's the number that they want in this box. Then when we find our reference angle, we're going to find arctangent of -4 over -2. This is going to become positive over positive. The signs will cancel, meaning it's going to return an angle in quadrant 1 when I find the arctangent, but I don't want an angle in quadrant 1. I want an angle in quadrant 3 since x and y are both negative. So I'm going to just right now go ahead and add 180 degrees to this. Arctangent of 4 over 2. And then I'm just going to pop in a plus 180 degrees to get myself in the right quadrant. And they want me to say that this is equal to 243.43. Again, 2 decimal places for everything. They're going to call this theta. I need to find n theta now. So n theta, 5 theta, is going to be 5 times 243.43 is going to be 1217.15. And then they're going to want me to subtract 360 and do that again. Do that again. And now I'm between 0 and 360 degrees, and they want me to use 137.15, 137.15. You'll see how different this answer is from if you would just stick it in the calculator. If you want to do that and change it from rectangular to polar mode and round those numbers to 2 decimal places, you'll see that you'll get slightly different values for r and theta. But let's just go ahead and leave this. This next problem, 2 to the 5th, is going to be 32. 120 times 5 is going to be 600. I'm going to subtract 360 from that and get 240. 240 is within my 0 to 360 range. There we go. Next one here, we're going to find our r and theta and use DeMoivre's theorem. So r is going to be the square root of 5 squared plus 4 squared. Square root of 5 squared plus 4 squared is, and we're gonna, again, round this to 2 decimal places, 6.40. Then we're gonna take that r and we're gonna raise it to the third, is 6.40 raised to the third. We get 262.14. However, they didn't get that, so let me just take this whole thing this time. This time I think they want you to use the entire number and cube it. Yep, that's what they want you to do. So we're just going to take this and call this 41 to the 1/2 power. And when I cube that, I'm going to get, it's exactly equal to 41 to the 3/2 power. And then that's going to be approximately 262.53. So again, you're going to see different problems. They're going to work different ways sometimes, even if it's in the same homework section. You've got to do it the way that they did their problem to get the answers the same way they did to get the right answers. So we're going to keep all of our decimal places here this time and round one time at the end. That's actually preferred to do that. So second arctangent now of 4/5. We are in quadrant 1, so this is going to give me 38.65 something degrees. I'm going to multiply that by 3 to get my n theta, and I get 115.98 degrees. And there we go. Convert that expression to rectangular form, 262.53 times the cosine of 115.98. We're going to get, and then they want us to round that to an integer, so we're going to get negative 115. Then we're going to take 262 times the sine of 115.98, and they're going to get, when we round this to an integer, we're going to get plus 236j. And then we're going to actually just use the calculator here, or we could do it the long way by hand, but I'm just going to use the calculator here to say what's 5 plus 4i raised to the 3rd power, and it tells me that it's negative 115 plus 236 times the imaginary unit. So that's exactly what we got there. We just had a little bit of rounding error here because of rounding error up here, but you see how we got a much more exact answer just sticking it into the calculator right away. All right, now let's go ahead and let's find some square roots. This is going to take a little bit of space. Bear with me. So what we're going to do is we're going to get the first answer from the first revolution around the circle, and then the second answer from the second revolution around the circle. We're going to get two different answers here, but they're going to have the same r value. So r is going to be the square root of 49, which is going to be 7. And then we're going to take half of 120 is going to be 60. Now if I take that 120 and I add 360 to it, is 480, and then I divide that by 2, I get 240. And those are in different quadrants. 60 degrees is here, 240 degrees is down here. So this one's going to give me positive x and positive y. This one's going to give me negative x and negative y. But they're both going to be answers to the square root of this complex number. So let's go forward. Let's actually find some roots using that method. Now this time it's a cube root, so we're going to get 3 answers. So we're going to have to go around the circle 3 times. So let's go ahead and find what r is. R is going to be the square root of 3 squared plus 2 squared is the square root of 9 plus 4 is going to be 13 to the 1/2 power. I'm just going to leave it like that. And then I'm going to say that r to the 1/3 power is going to be 13 to the 1/6 power. Let's take 13 to the 1/6 power. And we'll approximate that to 1 decimal point is 1.5. And now let's find our theta value, that's our reference. So we're going to find arctangent of 2/3. We are in quadrant 1, so it's returning the proper angle here. And then we're going to say, okay, our first root is going to be, we haven't called them z yet, but I'm going to call it z for the complex number, was 1.5 times, and then when I divide this by 3, since it's a cube root, I'm going to get 11 cosine of 11.2 degrees plus j sine of 11.2 degrees. And that'll be my first root. My second root is going to be the same r, 1.5 times, and now I'm going to go back to this here, but I'm going to add 360 to it. And then I'm going to divide that by 3. I'm going to change this to be cosine of 131.2 degrees plus j sine of 131.2 degrees. And then my third answer is going to be 1.5 times cosine of, and I'm going to go back to here. I'm going to add another 360 to this and divide that by 3. And I get 251.2 plus j sine of 251.2 degrees. And then I'm going to have to write my answers in rectangular form. So I need 1.5 cosine of 11.2 is, and then we're going to make this 1.5, then 1.5 sine of 11.2 is plus 0.3 j. 1.5 cosine of 131.2 is negative 1.0. Then 1.5 sine of 131.2 is going to be negative 1.1 j. And then z3 here is going to be 1.5 cosine of 251.2 is negative 0.5, then 1.5 sine of 251.2, and I get negative 1.4 J, and I'm just going to tell you I haven't been able to figure out right now what they did, but they got negative 1.2 here, J, and they got negative 1.5 J, so there were some differences in how they rounded. Just go ahead, and if you get an answer like I did and it doesn't accept it, try going a tenth up or down, see if it's just a rounding thing. So use DeMoivre's theorem to find the square roots of the following number. Be sure to find all roots. So let's find r is the square root of negative 2 squared plus 6 squared is the square root of 4 plus 36 is the square root of 40 is 40 to the 1/2. And then square root, so r to the 1/2 equals 40 to the 1/4 is about 2.51. Just call that 2.5 because they said to use one decimal point. And our theta is going to be arctangent of 6 divided by negative 2. And we need to add 180 degrees to this because we are in quadrant 2, not in quadrant 4. X is negative and Y is positive. So our theta reference here is 108.43 degrees. And then we're going to take 108.43. We're going to cut that in half, and we get 54.2. So you get 2.5 times the cosine of 54.2 degrees plus j sine of 54.2 degrees. We'll figure that one out in just a second. That's Z1. Actually, let's figure it out right now. 2.5 times cosine of 54.2 plus I sine of 54.2. And we get, this one is 1.5 plus 2.0j. Let's figure out that Z2 is going to be, let's take this 108.43. Let's add 360 degrees to it. And let's divide that by 2. And that gives us 2.5 times the cosine of 234.2 degrees plus j sine of 234.2 degrees. Let's type that in. Times cosine of 234.2 plus I sine of 234.2, and I get negative 1.5 minus 2.0j as my two square roots. So 1 1.5 plus 2.0j, and 1.5 negative 1.5 minus 2.0j are my two answers there. Now let's go ahead and see this pattern that 2j is going to lie on the y-axis here. And when I take square roots of it, I kind of deduce a pattern that they're going to have the same numbers but the opposite signs, because it's going to be related to the fact here that we get things that are based off of 45 degrees, and they are root 2 over 2, root 2 over 2, and negative root 2 over 2, negative root 2 over 2. So there should be some kind of pattern that I can induce here about how this is going to work out, even if I change from 2 to 150. So let's try and just change the 2's to 150s here and see how this works. So we should get over here square root of 150 times cosine of 45 degrees plus j sine of 45 degrees. And this is going to be our z1, and our z2 is going to be root 150 times cosine of 45 degrees plus j sine of 45 degrees. So this is going to be root 150 times root 2 over 2, or let's call this root 1 over root 2 plus 1 over root 2j, and that's going to give me root 75 plus root 75j, and this is 5 root 3 plus 5 root 3j. And now these should just change sign and be negative 5 root 3 minus 5 root 3j. Shouldn't even have to go through the work for that. All right, that's it for this video, and we will come back next time and talk about 12.6 Objective 2. See you for the next video.